Alright, welcome back. So first thing I'll say, if you check your answer and yours is different, don't erase it yet because I did something incorrect here for a reason. So the first thing I did here, and again on the surface it doesn't look like it did anything wrong. I had my two missing angles here. I now have a side angle pair with the x and the 22 degrees because we already found x to be 8.3. So I use sine law here. So I have sine theta over 20. It's sine 22 over now 8.3. And I solve, no problem, I solve for theta, and it gives me 64.5 degrees. And then I use my sum of the angles in a triangle theorem, the fact that they all add to 180 degrees, to solve for alpha to get 93.5. Now, you always got to think, do our answers make sense? And this is where, even though on the surface it doesn't look like it did anything wrong, this is where everything kind of falls apart because um, the longest side I have in my triangle is the 20, and that has an angle of 64.5 degrees across from it. The side of length 15 has an angle of 93.5 across from it. And that doesn't make any sense, because one thing you may remember is that the largest angle is always across the longest side, and the shortest side is always across the smallest angle. So that is not working here. And again, the problem that we're having is the same thing that popped up in the couple of examples ago. It actually turns out that we have an obtuse angle in the triangle. We didn't know that when we sketched it out, but it turns out we do have an obtuse angle. And we would have no way of knowing that necessarily unless we went through this and discovered that our final answer doesn't make any sense. So it should turn out that the first angle I solve for is actually obtuse. Now, you might wonder, well, how am I going to know until I solve and check? That seems like a lot of work. Well, one way you can avoid this, because right now, again, the problem lies is that if an angle turns out to be obtuse, if we use sine law to solve for it, we wind up getting some ambiguity. We don't know if the answer that we get is actually supposed to be an acute angle or an obtuse angle. So the way we're going to get around that is when you have to solve, when you decide to use sine law in a situation like this to solve for an angle, solve for the smallest angle first. Because we know the smallest angle that's left has to be acute. You can't have more than one obtuse angle inside a triangle because you'll have two angles more than 90 degrees, which means you have more than 180 degrees inside the triangle. So you know the smallest angle that's left has to be an acute angle. So let's solve for the smallest angle in the triangle first. And the way I've drawn, solve for alpha. How you know it's smaller? Because again, the side length of 15 is smaller than the side length of 20, so angle alpha across from the 15 should be smaller than angle theta. Okay, so we can always get around it. If we're going to use sine law, solve for the smallest angle first. It will remove that ambiguity and not make you worry about whether or not you're solving for an angle that should be obtuse or acute. Because when we solve for it, we know the answer is going to be acute. We can use some of the angles of the triangles to get the third one, and we know our answer is going to be right from there. So let's try this again. But instead of solving for theta first, because that was the larger angle, let's solve for alpha first. Okay, and let's see what happens. Okay, so again, starting from scratch, my sine 22 over 8.3 is still fine, but I'm now going to have sine of alpha over 15. Okay, so I'll solve for this. Again, same process as before, just solving for a different angle. Okay, and we run that through our calculator. I get 42.6 degrees, which makes a lot more sense than the original answer I got for alpha, which was 93.5. So now that I have that, I can solve for theta. So the last angle will be 180 degrees, minus the 42.6, minus the 22, so that gives me 115.4 degrees, which again makes more sense. I know it doesn't look like we have an obtuse angle drawn in here, but again, it's opposite the largest side, so it makes sense that that could be a possible answer. Okay, so it seems a little tricky now to have to worry about possible ambiguity. So one way around it that I mentioned was that if you have to use sine law to determine the other angles, always solve for the smallest angle first. That will get rid of the ambiguity. The other option that you have is cosine law has absolutely no ambiguity to it whatsoever. Cosine law will always spit out the right angle because cosine law isn't positive for both an acute and an obtuse angle. So the other option here is to always use cosine law to solve for the angles. Okay, and again, you won't run into the same situation that we ran into before because there will be no ambiguity at all. Okay, so a couple ways to get around that problem. Okay, so let's just try now one word problem, and then I'll give you guys a chance to practice it. Try and just set it up on your own first. Once you have it set up, it's usually not too bad. It's just a matter of trying to figure out what law to use from there. But try and draw a diagram first, and then check your diagram with me before you go ahead and solve it. Okay, so take a quick check of your diagram here. So the first thing that the plane does is it flies 80 kilometers due south. That's its first line right here, going straight down vertical 80 kilometers. So and it adjusts its course 15 degrees eastwards. It means it turns 15 degrees to the east from there, and then travels for 140 kilometers. So it makes a 15-degree angle with the vertical, but starts traveling now southeast. And the length of this line is going to be 140 kilometers. We want to know how far they are from their original position. So we started up here, we end down here. We're looking for that distance there. Now, right now it looks like we have two sides. We don't have any angles inside the triangle. However, this 15 degrees with the angle inside the triangle, they're supplementary, so they add to 180. So this angle in here is going to be 165 degrees. Okay, so I have two sides that contain angle. I can use cosine law. So I'll have d squared equals 80 squared plus 140 squared minus 2 times 80 times 140 times the cosine of 165. Okay, so I just have to solve for d. I'll let you run that through your calculator. You should get about 218.3 kilometers. Okay, then you can write out your conclusion, and you're done. Okay, so that's it, that's all. Again, so we saw a few sort of tricky things that can happen with sine law, cosine law, especially when we're dealing with some obtuse angles. We'll see a couple of other weird situations coming up in the next couple of lessons, but other than that, that's it for today, and there's some practice there just to reinforce everything about sine law and cosine law from grade 10. Alright, that's it.